Welcome back, students. In this video, we will discuss about trigonometric identities. So far, we have completed the theory part of trigonometric ratios, sample problems, theory part of specific angles, as well as the sample problems. Presently, we are in trigonometric ratios, trigonometric identities. Students, there are three trigonometric identities. These are also called as Pythagorean identities. These three will be very important for your solving most of your problems in trigonometry. Memorize this well, and whatever I'm going to teach you in this and the next two videos, please write and practice. It's not only about this memorizing this equation. There are different forms of this equation, right? Sine square theta plus cos square theta is equal to 1. That's fine, but there are multiple forms which it can take. So I will discuss that so that you can understand the relevance whenever you see the problems and detect the patterns. So please write and practice. Essentially, all the three are the same equations. Why I say this, we'll see in the next two videos. Presently, in this video, we'll focus only on sine square theta plus cos square theta is equal to 1. So, how do we prove or understand how the sine square theta plus cos square theta is equal to 1? So, consider a right angle triangle ABC where theta is at C. So, I apply Pythagoras theorem here. So, the hypotenuse AC square is equal to AB square plus BC square. Now I'm going to divide both sides of the equation with AC square. So it becomes 1 is equal to AB square by AC square plus BC square plus AC square. I need to take out this. I need to actually take out this and make the full square outside. I need to put it like this actually. I made some mistake here. I'm sorry. It should be something like this. So what is AC by BC? AB by BC. AB is opposite side. AC is adjacent side. The hypotenuse. So opposite side by hypotenuse. Similarly, BC is the adjacent side to theta and AC is the hypot. So it is adjacent side by hypot whole square is equal to 1. We all know that opposite side by hypotenuse is nothing but sine square theta and adjacent side by hypotenuse is equal to cos square theta. That's how you get the sine square plus cos square theta is equal to 1. Now this alone is not sufficient. By just playing around this equation, you get multiple forms, and understanding these forms is very important for you to solve the trigonometric problems. So this form, whatever I'm going to teach now in the next two videos, kindly write twice or thrice till you familiarize yourself the pattern. So let us see the form 1. Sine square plus cos square is equal to 1. So sine square is equal to 1 minus cos square. I am taking it to the other side. I am taking this cos square to the other square. It becomes 1. So this you can relate this as 1 minus cos square is equal to a square minus b square. You try to relate this way and apply that formula. A square minus b square is equal to a plus b into a minus b. So 1 minus cos square becomes 1 plus cos a into 1 minus cos a. This again you can rearrange by having this on one side, 1 plus cos theta on one side, and sine square theta and 1 minus cos theta on the other side. So there are problems which will give something like 1 plus cos a or 1 minus cos a and try to solve. When you see that, you must be able to relate that it is somewhere related to this basic form sine square plus cos square is equal to 1. Similarly, you can rearrange the other way where we can keep 1 minus cos theta on one side and bring sine square theta by 1 plus cos theta on the other side. This awareness is very important. Please do write and practice. Form 2. I am just going to keep cos square this side LHS and going to push the sine square onto the other side. So the equation becomes 1 minus sine square theta. 1 minus sine square theta is equal to, apply the formula for a square minus b square, which is nothing but a plus b into a minus b. So same thing I'm applying here. 1 minus sine square theta decomposes to 1 plus sine theta into 1 minus sine theta. And again I can rearrange, having 1 plus sine theta on one side and bringing this 1 minus sine theta to the other side, it becomes cos square theta divided by 1 minus sine theta. Excuse me. Same way, 1 minus sine theta also you can return on one side, push this 1 plus sine theta to the other side and the equation becomes cos square theta divided by 1 plus sin theta. So whenever in the problem you see 1 plus sin theta or 1 minus sin theta, you should be able to identify the pattern and relate it to sin square plus cos square is equal to 1. This is form 3. I will not tell it's a direct modification of the initial equation, but sin theta plus cos theta, that is a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. That's what I'm going to apply it here. Sin theta plus cos theta whole square is equal to sin square theta cos square theta plus 2 sin theta cos theta. Since you know sin square theta plus cos square theta is equal to 1, you are going to rephrase this equation as 1 plus 2 sin theta into cos theta. Somewhere you see this way, sin theta plus cos theta whole square or 1 plus 2 sin theta cos theta, then it is related to this trigonometric identity. Form 3 is nothing but a slight modification. Instead of sin theta plus cos theta, I'm going to put sin theta minus cos theta is equal to sin square theta plus cos square theta minus 2ab, that is 2 sin theta cos theta. I know this value as 1, so I'm going to put it as 1 plus 2 sin 1 minus 2 sin theta cos theta. So how does this awareness help you? See, for example, this is one of the problems. The moment you see this pair 1 minus sin theta into 1 plus sin theta, you must see this as 1 minus sin square theta, which is nothing but cos square theta, which is nothing but cos square theta. You see, saw here 1 plus sin theta into sin theta is equal to 1 minus sin square theta, which is nothing but cos square theta. In this problem, when you substitute cos square theta, this is the trigonometric identity 2, which is secant square theta. Secant square into cos square becomes 1. So we'll discuss the problem part more in detail subsequently. But what I'm trying to say is understanding these different forms is very much essential for you to crack the problems of trigonometric ratios. Consider this problem. Sin square theta. You can write this as 1 minus cos square a. 1 minus cos square is nothing but 1 plus cos a into 1 minus cos a. Then you have 1 minus cos a in the numerator, 1 in denominator, and you can easily cancel it, and whatever is left out is 1 plus cos a. That you can further simplify and you can get this equation. So understanding this pattern is very much essential. So practice those, write and practice this a few times, and next video we will discuss about the trigonometric identity too. Bye till then.